So this is question 22 from this week's assignment, having to do with the Compton Effect. So the big idea with the Compton Effect is that the EMR shows conservation of momentum when it was colliding with a metal, which is a very particle-like thing. So we know momentum's conserved. When we look at our momentum, the incident X-ray and the scattered X-ray, so we know that momentum has to be conserved in both dimensions. So initially, my initial momentum is all this, right? This is my initial momentum. Everything has to be equal to that. So if my X-ray has a Y component, my scattered X-ray has a Y component of 2.40, my electron has to have a Y component of negative 2.40. The only reason it's negative is because it's going down. But we know that those Y components, they need to cancel out. So we know that. The other thing we know we can find out from the X-ray is we can figure out its X component. We have the X-ray here. So it's going there at 45 degrees. So this is its actual momentum, but it does have an X momentum and it does have a Y momentum, which we know, 2.40. So we know an angle and we know a side, so we can find X. Tangent of 45 degrees is equal to the opposite side, 2.40, over my momentum in the X direction. So 2.40 divided by the tangent of 45 degrees is 2.4. And I guess that makes sense because it's a 45-degree angle. So 2.40, but we just showed, I guess, with trig that it is, in fact, 2.40. So that's the scattered X-rays X component. And then we can find out the scattered electrons X component, because again, momentum needs to be conserved. So initially it was 3.52, afterwards it was 2.40. So the remaining momentum is 1.12, is the remaining momentum of the electron. So we can find those components for the electron because we know that momentum's conserved and it needs to be conserved in both the X and the Y dimension.